You should be going over the homework, make sure each other. I think only one student that does that. Um, by the way, this on the homework, one of them is f of x. I didn't take a picture of this part. I just fill in f of x, g of x. Top part is f of x, bottom part is g of x. But that's homework. So here's is the first question. The first question is actually C. The reason why it's C is the first one, FA does not equal to FB. So if it does not equal to each other, so the first one actually doesn't apply. But if you pay attention, this one FA equal to FB, this one FA equal to FB, but there's an open circle, so it's not continuous. So only the C is qualified for Rolle's value theorem. Rolle's theorem. The second one is it's not continuous in graph 2 and it's not differentiable in graph 3. So there's only C is the only correct answer. Any questions? What'd you say, Jacob?
Someone snuck a piece of gum on top of the desk. They couldn't even stick it under the desk.
On your desk?
Yeah, it's right there. A blue piece of gum on top of the desk. Who's there here another period?
I'm trying to think. It can be her. She said Elizabeth. The rower Elizabeth. Ellie Mae.
I bet it was Ellie.
Ellie Mae won't do that.
No, I bet it was, bro. I wouldn't be surprised.
Ellie Mae. You should take a picture and send it to her. Ellie Mae, is this you? Ellie Mae will not do that. She's all right. All right. Was it debate in Discord over the weekend? Okay. So three is a good question. I want to go over three very, very extensively. It turns out usually a lot of students usually like struggle with this type of question. If you want to get a 5 or you want to pass the AP exam, this is a question to go to because if you really understand it, so let's just say you're bad at math, but you're good at reading, this is actually something very helpful. So let's go through each this choice one by one, you know. So to tell you the funny thing is about, you know, how this question of 5 choices, the average score on AP exam usually being 70 out of 108 from the last 30 years. It's always 70 out of 108 to get a 5. But a long time ago, they actually had 5 choices. So this is when I was in school, 1997, when there's 5 choices. And not only 5 choices, each choice you got each question you guess and you got it wrong, they take a quarter points off. So it's actually lower your score. About 2005-ish, they changed that the penalty taken away. So there's no more penalty for to guess the multiple choice. About 2015 or 17, they changed to 4 choice. So 45 question, even though the score average score is roughly the same, it's being inflated about 30 to 35%. So because it went down from 5 choices to 4 choices and also take away the penalty away. What I think it should have penalty. If with a penalty and not now the average score for 5 probably would be like, I don't know, 56 points rather than 70 points. So the student skill has went down a lot. But I like those questions because there was 5 choices, and so I give you homework about those questions, the 5 choices, and also like this kind of question you require to read and understand. So not only you have to understand which one is the right answer, it's really easy to pick the right answer, but you have to read why those answers are wrong. So we're gonna go backwards. We're gonna go E. Can somebody tell me why E is wrong? Raise your hand if you do know. It is wrong, by the way. Max? No, it's like I don't give. I just put a multiple choice. It's a C. That's it. Jacob.
The only thing that I could pick up on by reading that is that it says it's continuous, but it doesn't say it's differentiable. So Rolle's theorem probably doesn't apply.
You're right um in uh in yes, you're right. But there's also something kind of critical when you are talking about all. Yeah, you're right because it does not say differentiable, but they say all x. Could be some x, but not all x. Like when they say all like this, it's very dangerous to like just saying like I was trying to explain to a student that way too. Like you know, those always statement usually the most dangerous to pick because the always statements like saying even math, I don't want to say always this way. It's always true this way. So like say, just come up with a chemistry statement. Just says, is water always boil at 100 degrees? That's actually a false statement. Do you know why water is not always boil at 100 degrees? Because of pressure. If you go Mount Everest, the water is gonna boil at 85 degrees rather than 100 degrees because the altitude is different, pressure is different. So you cannot say always, like when you say always, like all x like that, that's a very dangerous statement to pick when especially proving which one to be true. Because always is something like it's just like give you hints on how to solve problem. Now, so yeah, Jacob is right because it never says not differentiable. It only says continuous. It never says differentiable the whole x. So E is not correct because you could have does not exist. D, what's wrong with D statement, Jacob? Not Jacob, Lee. Since Andy is not here, so we had to pick another Andy level. F of x equal to 0. Emma.
Well, doesn't it say f of a equals 0? So
It does say f of a equal to 0. It also says f of b is equal to 0. But what does f of x equal to 0 mean to you? I know there's some people knows, but I'm not calling them. How about the leader? What do we think? F of x equal to 0. What does that mean?
Oh,
You don't know. Fabian?
I mean, if you plug anything for x, wouldn't it all be 0?
Yeah, but what's f of x equal to 0? And more specifically, what's that statement called? Oh, Jacob's on the roll today.
If you if you graph that out, it would be just the y-axis would be stuck at 0 permanent.
You're almost right. You're almost right. It's that f of x equal to 0 is not y-axis. It's actually x-axis. Yeah, no, you're right. So the graph is basically from A to B is like this, is like this. This is a graph. It's always equal to 0. But it doesn't have to be always. This is f of x equal to 0. This is always statement too. Like 99.99% of function does not look like this. Does not look like a horizontal line because there's so many. It says continuous. I can be this is continuous. I can be like this is continuous. All different ways continuous. So D is not correct because f of x equal to 0. You have to understand f of x is y. Y equal to 0. That means this is equal to 0. Now, what's your statement C? Like f prime of x equal to 0 for all x such that a less than x less than b. What does that look like, first of all? Then what does that look like? What kind of line? Straight line, a vertical line, or horizontal line? Okay, yeah. It could be at any value this time. The C D statement is at 0. but C statements could be anywhere. So up and down could be anywhere, but long as you have a horizontal line, it's f prime of x equal to 0. Now again, the function doesn't have to be like this. It doesn't make sense that function had to be this because it just say f of a equal to f of b. That's it. Okay, let's say B. Is it B? Anybody pick B for answers? Okay. Oliver? Samuel? Who else? Apple? Anybody else? Fabian? Okay, so 1, 2, 3, 4, 5, 6, the end. Miranda? Wow, all the A students. Gleader? End up, all those A students are not correct.
You saw how I did the right time?
No, it's okay. It's good. It's good that you trick. Why this question only trigger the A students? No, it's okay. I think like a lot of time people are embarrassed that they are wrong, and I can't stand that. If you're wrong, just own up to it. Says you know I'm wrong, and that's it. And no big deal. Move on to the next idea. Why you're wrong, Lian? Do you know why it's wrong?
It doesn't always have to mean 0. It can also
Yes. And why is that though? Why you say that?
because that's one of the rules. You're finding where the derivative is equal to 0 or it's undefined. So it's not a must that it's only 0. It can also be undefined.
Yeah, but you did not state the obvious. Oliver, what do you think? Yeah, it doesn't make it differentiable. It never says. Jacob was right about that. It's not necessary, right? Necessary. I don't know how to spell necessary. Whatever. No idea how to spell. Not necessary. Differentiable. So it could be differentiable. It doesn't have to be differentiable. If it's differentiable, this will be true, but they never did say that. So these 1 point. So this looked like Rolle's-Bowie theorem, but it's not correct because Rolle's-Bowie theorem require the condition of differentiable, but it doesn't have that. So it's only one. It says it may not exist for all x. It may not because it never says differentiable. So that one's the only true statement. Now, if you realize all other statement is like kind of like always statement, those always statement is very easy pick on false situations. And you have to go back and figure out what a false situation is. Anyway, that's the moral story. This type of question, make sure you get it right. Next time, read it carefully. And that's okay. And both Miranda, Lian, Oliver, Apple got a good score on the last test. Marissa's, yeah. If you did good on the test, you had to make sure that every small little thing also had to understand. And those small things that you can improve. Every time you find that something you can improve on, that's actually something to be excited about because those are the things that you say, okay, well, those are things I can improve, rather than just always score A. Number 4, I got 15 over 3. Square root 15 over 3. I need to rationalize that. 5, I'm going to take a derivative, set equal to 0, x is equal to 1, so C. Number 6 is E. The reason why is they never have a condition FB equal to FA. And this is especially only for Rolle's-Bowie theorem. So you're going to say, I never talk about mean-value theorem. Yes, it's true because I never talk about mean-value theorem until today. 7, I'm going to take a derivative. I'm going to be cosine of x minus sine of x. I can move the sine of x to the other side. I can divide by cosine on both sides. So if I divide by cosine on both sides, I got 10 of x equal to 1, x equal to pi over 4. Now this one, I want you to be careful. Square root of 9 minus x squared. Lian should know what a graph look like now, right? But we spend a lot of time like thinking about what a graph look like for competition on Friday. They are doing competition team stuff. So what does square root of 9 minus x squared look like? Which is interesting. This is actually y, right? Now, what you guys need to know is, for SAT, you need to know x squared plus y squared equal to r squared. This is a center at 0. If you have center at different places, it's going to be like this. So you might want to write down because that's something very, very useful for SAT. If you ever see something x squared, y squared, more likely they are a circle equation. Now, let's just say if today this is a 4. So x squared plus y squared equal to 4. If I really comes down to do it, I can subtract x squared on both sides. So that's going to be y squared equal to 4 minus x squared. Y is equal to square root of 4 minus x squared. Then it's going to be a plus minus because you got square root both sides. So the plus part is this. The plus part is the negative part is this. So that's why you complete the whole circle. The plus part is the square root of 4 minus x squared. So you need to recognize this because later on, Lian knows that she already doing integrals and when doing area under the curve. That this one you don't need to do integral. You just need to find out the area of circles, which is gonna come back to help you. But if I were to take a derivative, it's gonna be 1/2 9 minus x squared to the negative 1/2 times negative 2x. If you set it equal to 0, x equal to 0, which is true because top part of the circle is 0, which is at x equal to 0. So you don't even need to do math. You can just understand that's a circle. The only time it's going to be like that. Now you're going to say, how about 3 and negative 3? 3 and negative 3 is not included because that's an endpoint. If it's an endpoint, it's not part of Rolle's theorem. If you take a derivative, this is going to be that square root of 7 over 3. Okay, hopefully you guys have no question on the derivative part. If you do, let me know. I can answer you. Yes, no, maybe? Now let's start with talking about the most common theorem on AP exam. So the most common theorem is IVT, intermediate value theorem. It's rank number 2. Sorry, I'm gonna rank them. Rank number 2, and this is just theorem. Rank number 1 is actually mean value theorem. That's the most popular theorem. The third is going to be Rolle's theorem. So that's ranking as far as the theorem goes. Now those definitions, definition continuous, differentiable. Definition differentiable is the highest rank for us in the situation. Now Rolle's theorem, I'm going to review again. It says f of x is continuous between a comma b, endpoint is included. F of x is differentiable between a to b. Now f of a equal to f of b. That's a 3 condition. So 1, 2, 3. And this is by Michael Rolle. And they say there is these 1c where f of prime of c is equal to 0 between a and b, not including endpoint. So endpoint is not included. So endpoint is not included. And this is very, very important because 3 and negative 3 is not included on a semicircle. So endpoint is not included. IVT, we already talked about it before. Just make sure they go to a certain value. Mean value theorem is kind of like IVT, but it's in terms of derivative. Now, who divides the mean value theorem? Mean value theorem about happened 30 to 40 years after the Michael rules by another person named Joseph. It doesn't really matter if you know the name. Lagrange. Joseph Lagrange. Joseph Lagrange is actually he's actually a justice in the court. Um, yeah, and he's a mathematician. A lot of time, like those time, like people who are politicians also are mathematicians. It's kind of like a in European history, like talk about Renaissance men like Leonardo da Vinci, like, but back then like Pythagoras actually it's also a politician and all other stuff. So it's very common back then because I guess those people can afford educations. So Joseph Lagrange come up with a mean value theorem, and he says this third condition may not need it because the third condition f of a does not equal to f of b. It kind of like he feel like it's not necessary. So f is continuous between a to b, and f is differentiable between without endpoint a to b. Now what the result, again, if you pay attention on the rules value there, the third condition is like this, right? fa equal to fb. Now you just say, okay, well, somewhere along the line you're gonna have a slope equal to the slope of the green line. What is the slope of the green line? Slope is equal to 0. But this red line is equal to the green line. In this case, is twice. Twice. It could be 3 times, 4 times, 5 times, but it's not the endpoints. But this is slope of what? We know it's secant line. Slope of secant. Can I just focus on slope of secant line? So what I suspect is like Lagrange is kind of lazy. He kind of just like maybe move the paper in a different orientation. Like what I mean by a different orientation, instead of those fa equal to f of b, he says, well, fa equal to fb like this. So he kind of tilt the paper a little bit. He found out like what, or tilt his head a little bit, whatever, right? So he says, well, if I can find the slope between those two green dots, well, ooh, which girls? Oh, you sent me the name? Okay, let me check. Give me a second. Hold on a second. Jenny Zhao. Okay, and Fiona, and what else? Can I call you back? I'm gonna check on them. I don't know if I had a conversation with them. I don't remember. But if I did, I don't think they were late. But I'm gonna check. I'm gonna check with them first. Do you think I can call you back? Okay.
I don't.
Okay. Thank you. Um. FA equal to FB. So if I were to take the slope between those 2 points, if I see the slope between those lines, which is the function could be look like this, right? The function could be look like this. It's continuous and differentiable. So this is f of x. Now, if I take the slope between those 2 lines, basically slope between those 2 lines is going to be f of b minus f of a over b minus a is equal to, well, somewhere along the line, they have the same slope as the green line. So around like this point right here, the slope is exactly the same as the green line. And then what they're saying is, instead of before it's a horizontal slope, in this case, this is actually a slope, it's not a horizontal. So C1 is equal to C2. So f prime of C. So f prime of C is the slope at a tangent line at some point. It's equate to the secant line. So this is the slope of secant line, slope of secant line is equal to slope of tangent line. Is that okay? Because now f of a does not equal to f of b. But between f of a and f of b, there is a slope. There's a slope. I will show you what happened here. If you go into Desmos like this, right? And if you just type in Desmos and the mean value theorem, actually you can do that for anything. Somebody already devised those things already. It's not me. I didn't do that. But you can take it as is. So if imagine that you have a point between, that says, oops, between like this and like this, right? So I'm dragging this tangent line here. So it must mean that somewhere along the line, there's a tangent, looks like that. Do you see that green line? Slope equal to. How many times green line occur between A and B? Probably twice, right? So it happened again here. It's really hard to adjust. Maybe 0. 0.15, maybe 1.6. Yeah. So you see that slope is equal to that. So it's really important that you know that. So this is just saying there is at least one C where f prime of C is equal to fb, but between A and B, not including endpoint. Again, not including endpoints. Okay, because on your worksheet, there was maybe a question that endpoint. You had to exclude that one. I'm going to give you a question. So f of x is equal to 5 minus 4 over x. And then between 1 to 4, okay, so let me ask you a question. Is this function continuous? Be careful how you answer this question. Is the function continuous? No. Where is not continuous? 0. But is 0 part of 1 and 4? No. So it is not continuous function. So the way I ask the question, is it continuous? It's not continuous. However, between 1 to 4 is continuous because not part of the thing. So the f is continuous between 1 and 4 because it's only not continuous at 0. And f is differentiable is between 1 to 4 because it's only not differentiable at 0 again. So then I need to take a derivative of this because, or I can find, so we are trying f prime of c is equal to f of b minus f of a over b minus a. So we're going to take a derivative of this. What's the derivative of this? Well, f of x is equal to 5 minus 4x to the negative 1. So if I take a derivative, what am I going to get? 4 over x squared. So 4x to the negative 2. Is that okay? And this is f of 4 minus f of 1 over 4 minus 1, which is average rate of change. This is 4 over x squared. If I plug in 4, I'm going to get 4. If I plug in 1, I'm going to get 1. So be 4 minus 1. So 4 over x squared equal to 1. X squared is equal to 4. X equal to plus minus 2. Only one of them categorizes this. Which one is going to be? 2, right?
The 4 to the power negative 2.
I take a derivative of this. Derivative 5 is 0. Derivative 4x is 4x to the negative 1.
The negative 1. Yeah, so I was oh, I see. I see.
Uh-huh.
When you were plugging in like F4 minus F1, did you plug it into
Original function. Yeah, I didn't plug in derivative. Okay, is that okay? So you guys can get started with the homework.